Thank you. So moving on to the last and one of the exciting parts for every business developer and those who want to develop in a low-code library, a machine learning end-to-end platform. Please welcome Mr. MOEEZ, who is a data scientist and founder and creator of the PyCaret, an open source machine learning library in Python. I personally know MOEEZ and he is an awesome person, humble, and you would love to learn about the PyCaret session from himself. So I would like to welcome MOEEZ to the stage and please share his screen and share his valuable knowledge around PyCaret with us.
MOEEZ, we cannot hear you. So you're on mute. Let me unmute you. Perfect. Can you please speak?
Can you hear me now?
Yes, perfect. But your video is like really blurry. Is there any better internet connection that you can connect to? Maybe data?
I'm using 5G.
Why are we still having that problem there? Okay. You can start just maybe zoom in a bit when you're showing code so that it's a bit visible to people. Okay, so I guess he's connecting to. All right, perfect.
Can you see my screen?
Yes, we can.
Okay, so let me. Okay, so you can hear me and you can see my screen in full mode, right?
Yes, perfect.
Okay, so shall we begin?
Yes, absolutely.
Hello, everyone. Good evening, good morning, good afternoon. It's a very early morning for me here in Canada, but I realize people are joining from different time zones. So good afternoon or morning, wherever you're from. Hope you guys are doing well. Thank you for joining today. My name is MOEEZ. I'm an analytics leader. I work for PWC Canada. I head Center of Excellence for North America, and I lead technical engineering teams. I'm a very passionate data scientist by night, very active open source contributor. Recently, I was working on a project for over a year, and in April of this year, we have open sourced it. It's named PyCaret. It's a machine learning library in Python, and this session is all about that. By background, I'm a chartered accountant, so I'm a member of CPA, CMA, CMA, but I don't practice accounting anymore. I have lived and worked in 3 different continents, and I have spent my career mostly in analytics and reporting in public sector organization. These days, based in Toronto, and in terms of situation here with regards to COVID, I think we are getting pretty much stable. Cases are going down, so we are hoping for the best that we'll be back soon, just like before. Okay, very active on social media. So if you feel like to stop by and connect with me on LinkedIn, Twitter, please feel free to do so. I'm also a very active writer on Medium. So here's my Medium link as well, in case you want to follow me there. Okay, some important links for PyCaret in our repository. So all these are links. All these links on the screen are really, really important. But the most important link is here, github.com/pycaret/pycaret-demo-IBM, because all the material, including this presentation and all the notebooks and everything else, is uploaded on this repo. So this is the one highlighted in yellow. This is what you need to clone if you want to follow along in the demo. This presentation is also included in the GitHub repo, so you'll get everything that comes with it, right? Okay, so before we get into the session, just want to make sure we only have 45 minutes today, but and we can only talk so much in 45 minutes, but there are a lot of resources on internet, and I have left few of them here, because you would get this slide when you clone the repo. You can actually go at your own time, go ahead and look at these resources. Some of them are notebooks, some of them are articles, some of them are video, but almost PyCarets integrate with almost every other BI tool, including Alteryx, Knime, Power BI, Tableau, and there's a tutorial on every piece of it, right? So I'll leave it there. Okay, so let's get started. So this is the high-level machine learning lifecycle that I'm sure many of you are already familiar with. What we using PyCaret, what we would cover today is just this this section on right, highlighted in red, which is basically training, tuning, and deploying your models in production. Whatever happened before this ETL pipeline and gathering your data and setting business objective, it's pretty much a standardized process, and every company would have different ways to handle it. What we are covering today here is this section only. Okay, so this is the high level diagram, but what I'm going to do is expand it, zoom it in this section, training section, and basically go through a granular ML lifecycle, a typical supervised experiment. So you define your business problem, you define your machine learning objective, collect data, analyze, you split your data into train and test set or validation set. Then if you have any missing values in data set, you impute the missing values, you perform different kind of encodings, you perform different kind of scaling, transformations, feature engineering, you do other zillion things. And the reason you are doing all these things so that you can train a model, and then you tune that model, you track the performance of that model, you blend that, ensemble that, you try different things, and your objective is to basically find one best model that you can take and deploy in production, right? That you would use for inference. The problem is you repeat this cycle so many times because you don't actually going into the experiment, you don't know which algorithm or which model would work best, right? So you repeat this cycle many times, and you generate a lot of metadata as you are performing the experiments. All the metadata like model itself, metrics of models such as if you are doing classification, AUC, accuracy, recall, hyperparameters of model, number of iterations, and you also have to track them based on time as well, right? So you generate a lot of metadata, and in order to do that, you also write a lot of code. So what is PyCaret? So PyCaret is an open source, which means free, end-to-end machine learning library in Python that help you automate your workflows in Python, right? It's easy to use, it's a productivity tool, and it's business ready. PyCaret can help you with data preparation, model training, hyperparameter tuning, analysis, selection, and experiment logging. And we would obviously, I'm running through it so that we can spend more time in the demo and have chance to answer some of the questions that you have today. So these are the things. At this time, we have the last stable release is PyCaret 2.0, and we support these 6 modules: classification, regression, clustering. So pretty much everything in classical or canonical machine learning. We don't support deep learning. We don't plan to include deep learning. Time series module is missing from this list, but it's already in development. So probably next 2-3 release, time series would be a separate module, as well as would be supported under regression module as well. Okay, so before we get into the demo, again, this link, clone this repo. If you want to follow along, all the notebooks and this presentation is uploaded there. github.com/PyCaret is our profile, and then the name of this repo is PyCaret-demo-IBM. If you are using or planning to use this on your local computer, local machine, then you need to do pip install PyCaret, either using Anaconda prompt or in the Jupyter notebook, doesn't matter. Installation may take 10 to 15 minutes. Okay, so before jumping into demo, I'll just pause on this screen for 30 seconds so that people who want to copy this can copy this. Or if somebody can actually copy this link and post it in the chat, that would be good. All right. Great. Okay, so let's move to demo. Okay, here is my. Okay, so here's my Jupyter notebook. I'm using it on my local machine, and if you are planning to follow along, this is the name of the notebook. There are 6 notebooks uploaded on the repo. I'm starting with this one, PyCaret 2 classification. Okay. Okay, so first chunk here from PyCaret utils import version. I'm checking the version of the library 2.0. Just want to make sure. Okay, PyCaret has a module called datasets, and in datasets module, we have a bunch of toy datasets that we have uploaded on GitHub. And for this demo, I'm using one of that data set. So in case you want to check what are the data sets available on repo, you can check the index, and index has the listing. So each record here is a data set, and then you can see some metadata along with that, right? So the data set that I'm going to use today is this one. Where is that? Juice number 14. It's a very small data set. It's a binary classification data set, so you have to choose between two type of juices based on about 15 attributes. Okay, so let me just load into the data set. So now I have this juice data set stored in my data variable as a pandas data frame. Obviously, when you're working with that, you would load your own data set. It doesn't matter how you bring in the data, either SQL or CSV. It doesn't matter as long as it's a data frame. PyCaret would work with it. Okay, so if you look at this data set, each row is a transaction in a retail store. And this is our target variable, purchase. CH and MM, these are two different type of juices. One is mango, Minute Maid mango, and one is something else. And based on all these characteristics, which is price of CH at the time of transaction, price of MM, the discount, loyalty index, sale price, store in which it was sold. Based on these attributes, we have to predict whether the customer would buy CH or MM. All right, so that's the objective. Anyways, any experiment in PyCaret starts with initializing setup. And when I say initializing setup, that means you have to basically initialize the setup by passing the data frame that you want to work on and the name of the target variable. So in this case, I'm passing data variable, which is actually this one, where I have my data frame stored, and name of target variable, which is purchase. All these things I'll come back later, but you actually don't need it. You can just run it like this, but I'll come back to these things later. Let me first go ahead and just run it. And if you see this line here from PyCaret.classification import star, this is basically equivalent of importing everything in this module. PyCaret is not it's functionally typed language, so it is a little bit different than how you would write your code conventionally in Python. So it is different in that sense, but there is no harm in using this style of importing if you're working in Jupyter Notebook. Okay, so as soon as I run the setup, the first step is PyCaret would automatically infer the data types of all column. And why it is important? Because obviously there are certain pre-processing techniques that apply to categorical data differently than numeric data. For example, if there are missing values, techniques used to impute missing values for categorical data would be, for example, mode, or creating a surrogate column, or most frequent value, which is equivalent to mode. But if there is a missing value in numeric data, it could be mean, it could be median, or there could be also other techniques. But the point being that determining the right data type is very important. So the first step is PyCaret would automatically infer it. If these data types are correct, you can go ahead and press enter. In this case, I'm going to go ahead and press enter because I know these are correct. PyCaret would also go to an extent by detecting the ID column. So in this case, see the ID, it has been detected as ID column, so that you don't have to drop this ID column and then rejoin at the end of experiment. If PyCaret would detect ID column, it would basically not delete it from the data, but it would hide it from the data for the purpose of model training. Same goes for date and time. If we detect there are date and time in the data, what we would do is we would first of all, we would say it here that it's date and time, but we would also extract the features from that column, 5 or 6 or 8 features, and we would hide the date column itself for model training, because there's no use of using that in training the models, right? But in this case, you can see I don't have date time, so that's fine. But rest of the columns, so let's go ahead and press enter because they're correct. Okay, and as soon as I press enter, setup is completed. I can see the message and I can see this big table here. This is my information grid. So anything that I did in setup, it would basically be, it will basically say here, right? So for example, if I read this table, if you notice that this is not encoded, right? This is CH and MM. This is not 1 and 0. So the one thing that PyCaret automatically did is encoded it into labels and have given you the map here. CH is equal to 0, MM is equal to 1. This is the shape of your data. PyCaret is telling you there is no missing values. There are 13 numeric features, 5 categorical features, and all these things, right? And then obviously PyCaret handles train test split automatically. So this one, so out of 1070 rows and 19 columns, your transform test set train set is 748 by 28 and 322 by 28. So if you sum up 748, 322, it would basically be 1070. And if you are thinking that original data had only 19 columns, why my transform set had 28? That's because if there were categorical features, PyCaret would automatically one-hot encode them. So you would increase the number of columns. There are other type of encoding available. If you want, you can do that. And these are all other pre-processing options. In our case, we haven't chosen to do anything. That's why everything is false. But to do anything, it's simple, because if you check the documentation of this function, all these are little switches of true and false. So if you want to do PCA, it is as simple as typing PCA is equal to true. That's it. Now you can see we have 2 columns only, because we one-hot encoded it, but we also applied PCA. So basically the sequence of pre-processing step is predefined, it's orchestrated, but you can simply choose true and false, and in some cases, some threshold. So for example, if you select feature selection is equal to true, it would also run classical feature selection methods. But if you want to restrict your space of features, you can pass a very aggressive threshold for feature selection, right? So there are almost 25 pre-processing options that are commonly used, that you can use them within setup. And what it would do is it would create a pipeline behind the scene, and you can use that pipeline when you are inferring your test data, or basically new data set in production, so that you don't have to manually not just manage it, but also manage the sequence of it, right? Okay. And also, I mean, if your data set is imbalanced, I'm saying because I get this question a lot, you can also fix imbalanced data set during setup function. You can just pass fix imbalance is equal to true. Okay. So once setup is done, so this process is common across all the modules. It doesn't matter you are doing classification, regression, clustering, anomaly, it's same. So, and the design of PyCaret it's not by fluke. It was intentionally made exact same, so that you don't have any learning curve, right? Because there's no point of learning 3 different types of code, because at the end of the day, what you want to do is get a model out of it which can generate inference, right? Okay, so once the setup is initialized in whatever module, doesn't matter, the first recommended path we recommend is this function, compare underscore models. So very powerful function with just one word. What this function does is it would go back, check out the model zoo, and all the models that we have in model zoo, it would train them using 10-fold cross validation by default. And you can see interactively it's updating on your screen, right? So it's using HTML, and it would fit all the models. I think for classification we have 10, I think we have 14 or 15 models, all the sklearns plus XGBoost plus SCATBoost plus Light GBM. And our plan is to not add more models, not to have a library of like thousands of models, because what we want is, like, you can use your own model in PyCaret. You don't have to use the pre-trained models from our library. As long as your algorithm supports .fit .predict argument, you can use anything. You can use them in PyCaret. Okay, so what this compare models is doing is basically comparing all the predefined models and checking their metrics using 10-fold validation only on train set, right? So this one 748, this is fitting all the models on this on the train set. Okay, let's give it a second here. Get boost is finishing. And by default it would return you the best model. So in this case, logistic regression, and obviously it is highlighting which model is best in which category. So you can see QDA is extremely good in recall, 76%, but obviously it is being compromised in terms of accuracy and AUC. So you can see respective categories, but logistic regression by default it would take accuracy. So logistic regression is the best model. This table, if you notice, is sorted by accuracy, but you can change the sort order using sort parameter here. So you can say sort is equal to recall, and then if you do sort is equal to recall, I believe QDA would be the model coming on top, right? So by default, it would return you the model on number 1 position. So in this case, it is logistic regression. So if I check my best model, this is nothing but logistic regression, right? So dynamically, so if I were to do this, sort is equal to recall, the model stored in best model would be QDA, not logistic regression, right? So it's all dynamic. Okay. The other function that you would find yourself using a lot is the most granular function in PyCaret, which is called create model. So just by name, statement create means create a model for me. That means train a model for me, right? So, and it is as simple as just typing create model. And LR denotes for logistic regression, DT denotes for decision tree, RF is for random forest. So very pretty much intuitive. But in case you wanna check, there is a function called models, just models. You can see the list of all models, right? So these are IDs, these are names, original implementation, blah blah blah, right? Okay, so what we can do is just simply run this. What it would do is it would train this command here, would train logistic regression on 10-fold by default, and here are your metrics. So basically this line would match with here, and you can see it's matching 82, 63, 89, 56. So this is the same thing. This table is basically average 10-fold for each of the model, and when you use create, you basically see results by fold. This is very important because sometimes you not only need a mean score, but if you want to check the stability of model, you also need the standard deviation, or you need to eyeball the results across the fold. So in this case, I can see, yeah, it's not a very good example to show you that, but sometimes it's really important you see the standard deviation too. Okay. So here I'm creating DT is a decision tree. If I want to create a 5-fold model, I would just simply pass fold is equal to 5. So in this case, you can see I'm training random forest with 5-fold. So you can see this is a 5-fold random forest, right? Okay, so that's just cross validation strategy. Is the same model. Okay. So you can also smartly use this models function because PyCaret is functionally written. You can nest functions within each other, just like Excel, right? So if you can use this function very smartly by selecting a subset, which is select only ensemble models. And then you can smartly nest these functions together. So you can use compare models, whitelist is equal to models. So basically this command here is returning you list of these parameters, and then if you're directly passing it compare models, it would first create compare models. It would, just like Excel, it would execute the internal function first. So now it is executing this. First it executed this, now it's executing compare models, right? In the next version, obviously we are adopting to the GitHub guidelines, and the parameter whitelist and blacklist has been renamed into include and exclude parameters. So the function is same, it's just we have renamed it to be more neutral. Okay, so just like create model, there is a function called tune model, which basically tunes the hyperparameters of model. In this case, I have created or LR, created or trained a logistic regression model, which is this one, LR. When you do that, it uses the default hyperparameters. But what you want to do is also check the hyperparameters of that model and perform different iterations to see if you can improve the performance of the model. So there is a function called tune model where you can simply pass the model. So here I'm passing tune model. I'm just passing my logistic regression model. What it would do is behind the scene, we have predefined hyperparameter search spaces, it would randomly iterate over it. And I think by default, it would iterate over it 10 times. And iter is equal to 10, but obviously you can increase it. And also, if you want to pass your own grid, just you can pass a dictionary of grid into custom_grid parameter. By default, it is optimizing for accuracy function, but if you want to optimize, let's say, recall, just pass optimize is equal to recall. Now, this may result in a different model than what we have seen previously, right? Anyways, in this case, recall went up to 8253. Let me check if, oh yeah, so it actually went, so from 7262, it went to 82 something, right? And let me also check the difference, why it did that. So my default LR and my tuned LR, yep. So you can see my default LR with 72% in recall had a C is equal to 1.0, which is the default in sklearn. When I tuned it, it found this iteration, this 3.931 as the best in all the iteration. And this is not the guaranteed result. Like if you change the iter to 25, this may further improve, right? Because you are actually increasing the number of iterations. In this case, it didn't. But if you want, you can do that. In future releases, what we are doing is also adding, because this is a random grid search. For next 2 releases, we are also adding Bayesian grid search, and we would also support the backend of tune model function would be just like Spark. It would support massive distributed processing. So that would allow you to be able to tune, let's say, GBoost on 70 million ROS. Okay, so just like create model, tune model, there is a function called ensemble model, which basically ensembles the multiple model together. So in this case, I am creating ensemble model on top of decision tree. And if you check bagged DT now, this is nothing but a bagging classifier, which is wrapping my decision tree inside, right? So you can see 85% in AUC for ensemble decision tree, bagged decision tree. But if you were to just see the normal decision tree, like one tree, it would be 75%. Normally, any tree-based model would improve performance during ensembles. Similarly, instead of using bagging classifier, I can do boosting trees. So in that case, I would just pass method is equal to boost.
By the way, there is a question here that which version of decision tree is used here, ID3, C4.5, or CART, or any other variant?
So it is a straight implementation from sklearn.
All right.
Okay. Okay, so just like so ensemble model is for bagging and boosting, but there are other ensembling techniques that you can use. So for example, blend models would create a voting classifier. So in this case, what I'm doing is, can you mute your mic? I'm hearing echo. Great, thanks. So in this case, what I'm doing is I have created a bagged DT and boosted DT, which is nothing but a wrapper around my simple decision tree. Here I'm blending them together. So I'm just passing these two in the blend models function. And let me show you when I run that. My blender is basically nothing but a voting classifier that wraps all these algorithms, right? Now, what you can also smartly do is, instead of running, you don't need to hard code this, right? This is just an example. What you can do is you can do this, compare models and select is equal to 5. So what it would do now is it would first run the internal function, which is this one. This function, compare models and select is equal to 5. By default, compare models return the best model. But when you pass the nSelect parameter, it would return a list of top 5 models on whatever category. So if you want it based on recall, you would also pass this, right? So when you do that, it would execute this function first. It would return a list, and then it would execute this function, right? So all being dynamically. So whenever you change your data set, now nSelect 5 is different. But again, it would dynamically do that. So you can create like a workflow that would work with any data set. Similarly, stack models. So if you don't know blending, when you take a softwood or hardwood of estimators together, but stacking is basically taking the estimation from the base level models and then passing them as an input in meta model. So in this case, I am passing bag DT, boosted DT, and tuned RF as my base level model, and then the predictions that these estimators generate, three of them, I'm passing to my meta model, which is random forest, a simple random forest, and then training random forest using cross validation, right? So that's stacking. I'm not going to run it. It might take some time, but again, the concept is same. You don't need to hard code it. You can do it like this, right? And select is equal to 3. Anyways. Okay. There is a function called plot model, which has a lot of interesting plots. That you would have to write few lines of code if you were to do it yourself. So by default, it would give you a AUC plot, but you can change the plot parameter to get different plots. So in this case, confusion matrix, boundary, and obviously with every passing day, we are increasing the plots because the way it's being structured under the hood is we can expand it horizontally, right? We have another interesting function called evaluate model, which is nothing but this one nice little UI. So if you are too lazy to run plot model individually, you can simply pass your model into evaluate. It would give you this UI, and obviously only on Jupyter Notebook or Google Colab or in any notebook environment, and you can just look at like this. It's the same thing. Instead of just passing individual plot, you can look at like this, right? Anyways, interpret model is another interesting function for model analysis. It implements Shapley value behind the scenes, so I can pass my tree-based model, which is XGBoost, CatBoost, LightGBM, decision tree, random forest, wisdom boosting class, or any tree-based method. I can pass it inside interpret model, and it would behind the scene it would implement the Shapley value, which is one interesting way to look at feature importance at a model level or at a prediction level. If you don't know about it, I do recommend read about that. It's a very interesting thing. It takes a little bit of time there is a little bit learning curve involved in order to read these plots. It's initially confusing, but once you get used to it, it's really good and it's really powerful. So in this case, I'm passing cat boost, plot is equal to reason, and observation is equal to 12. It means that whatever number 12 observation on my test set, this is basically the reasoning why model predicted whatever model predicted, right? So very important. Okay, and the last important function, AutoML. So what AutoML is doing is so whatever you have done so far in PyCaret in terms of model training and whatever you have done, we have a blueprint behind the scene, right? And what you can do, you don't actually, when you are doing your experiment, you don't need to remember these numbers, obviously, because if you train 50 plus model, it's not possible. You don't need to record them in Excel. You don't need to do anything, because if your selection is based on the metric and only metric, what you can do is run this function AutoML, and what it would do is it would basically go back and all the models that we have trained today in this environment, in the active environment, it would basically bring out the best model out of it. It would finalize it. That means it would also, you remember we have a split it, train, and test set, right, in the beginning. It would also not only bring out the best model, but that this time it would finalize it. That means it would fit it on the entire data set. So now you are ready for checkout, right? Now you can take this model and deploy it or do whatever. Predict model is a function, obviously, to predict on the new data set or on the test set if you don't pass any data set. So in this case, I am not passing anything, just predict model LR. So what it would do is it would basically predict on the test set. So this is my test set, and here's my prediction. So it would take the original data set and attach these two columns. Label is your prediction, 1 or 0. Score is your probability, just like predict proba and scalar. And these are the scores on your holdout set. But when you have new data set, you obviously don't have the label column to it. what you can do is just pass that new data set. Data is equal to new data. Obviously, you don't get this score grade because there is no label, but you would get the label and score column, which is basically the prediction and predict proper. Save model is how you save the model. So when I save model LR model name batch model, let me show you when I load it back. This is not just one model. You can see this is the pipeline of sklearn. This is not one model, right? So anything that you have done in this setup function. So you have imputed missing values, you have done 10 other things, and then you have created a PCA with the 80% retention. It would basically give you all those things in arranged in a sequence, so that tomorrow when you have new data set, instead of you manually managing it, you just apply or call predict on this object bash model, and it would take care of the rest. And if you want to see it graphically, these are your, so you basically, we started with this auto inference, which is data type handling. Then we have imputer. So whether there is missing value or not, we always create an imputer behind the scenes, so that when you have null values in production data set, we handle it. We don't throw an error instead. Okay, and if you were to choose PCA or any other things, you would obviously see the objects here. Okay. With this one function here, deploy model, what you can do is you can pass your model here, LR, under deploy model function, and just pass the authentication. And obviously by default platform is set to AWS. Not clear here. So this little function, this one line, what it would do is it would take your model and ship it to AWS. Let me just run it. Model successfully deployed on AWS S3. And if you have done a little bit ML ops before, you would realize it's not that easy. It's a lot of pain that PyCaret is covering behind the scene for you. Let me just exit out of full screen. If I show you my S3 account here now, there you see, this is the timestamp. This is the model that just gets uploaded to AWS S3, right? In next release, which is 2.1, which is due by next week, you can also deploy using the same pattern. You can also deploy it on GCP and Azure. So it's no different. Instead of AWS, you would write Azure. So very simple. Okay. Here are few utility functions. I'm not gonna. So they are in the notebook for you to check, but people ask me this question a lot. How do I see my transform train set? How do I see this? How do I see that? So there's a function called get config. See the documentation. You can almost customize anything in PyCaret. So there's nothing hidden. So do read the documentation. You can get or set anything in PyCaret. Just because it's not object-oriented programming doesn't mean it cannot do what OOP can do. Okay. It generates because many people, and then obviously the intention is to have people build projects on top of PyCaret, use it like a tool where they would design their own customized AutoML software. Logging system is obviously very important. So if you see get underscore system underscore logs, anything that you have done today, it has basically logged it in a very interesting way. And we use it for troubleshooting on GitHub, but obviously if you are building anything on top of it, this would be very useful for you. Okay, so the last thing I should talk about is, remember in setup function, you passed this log experiment is equal to true and experiment name is equal to juice1. What it is doing all this time behind the scene is logging every single hyperparameters, every single metadata behind the scene. So because I don't think so you as a data scientist needs to waste your time on logging these parameters in Excel or even try to remember them, right? So at the end of your notebook, if you simply run MLflow UI, and we are using obviously backend, we are using MLflow. In PyCaret 1.0, we were designing our own backend logging system. But then we realize it's a waste of efforts to duplicate work. If there is already a great work done by somebody, just using it. Okay, when you run this function here, MLflow UI. And if you're using command line, you don't need this this symbol. If you're using notebook, you need this exclamation mark. And then go to your Internet Explorer or browser and run localhost 5000. It would open up a Flask server on your computer, and you can see the experiment name juice one. Let me just click that. Here's your everything that you have done today. It's your scoreboard, just like a scoreboard in or leaderboard in any AutoML, except that it's a very functional leaderboard. You can work with it. So all the metrics here. Let me switch to a different view. So all the metrics here, all the model parameters, tags, and few other important information, like for example size of the model, right? Because sometimes that's also very important. So you can see extra trees classifier is on such a small data set is even 4833 KB compared to if you see other models, they are like 20, 30, 40. Anyways, if you click on the model, you would see all the parameters at a model level. You would see the metrics, tags, and you have a trained model as well. So at this point, because this is using MLflow and you have experience with MLflow, you can also use PyCaret's deployment capabilities. But also, if you are using Databricks, you can use model registries, you can use SageMaker deployment, you can use any kind of integration that already exists. So what we are trying to do is combining things. You also have a lot of deployment capabilities that you would get from PyCaret, but you would also be able to use the native deployment capabilities of MLflow. So that's really good, right? And if you want to, so let me just stop the server for a second. I'm restarting my notebook. Just want to show you one thing, and then we'll be open to questions. So instead of this, log experiment true, experiment name, if you also pass log plots is equal to true, right? If you do that, and now if I create any model, let's say and if I go back to my server now, I can, if you would see now, you have trained model, which you have seen previously, but you also have these plots here, right? If you want, you can log them. Now, the benefit of this is obviously I'm using it on my computer, but this is not how you use it, right? If you're using in a team environment, what you would do is you would set the server of MLflow, the backend, to S3 for artifacts, and then some kind of tabular data set for your metrics and params, right? So either MySQL or PostgreSQL or something like that. Then it's really powerful, because then your entire team, doesn't matter where they are working from, they are working in this system where everybody is logging their artifacts and models and metrics and parameters. And this is not just this is not just experimentation, but you can also do entire ML ops with this, right? Because there is a model registry as well, where you could register your model and have A/B testing with a stage model and a production model and stuff like that, right? Okay. And also, just last point before we open up to question and answer is it's a PyCaret is not an abstraction layer, and I know many, I don't think so many people like abstraction layers, libraries that just hide all the details under the hood. That's not what PyCaret is. PyCaret is meant to replace your boilerplate code, right? And it is as flexible, as customizable as anything else in the world. So for example, if I want to create a light GBM model, and when I say create, I actually mean train light GBM model, right? So I can just do that. But if I want to have a specific learning rate, I can train light GBM with a very specific learning rate, in this case 0.1, right? And you can see learning rate. Where is learning rate? Here, 0.1. So it's not an abstraction layer. So anything, as long as it exists in a light GBM, you can customize it. You can pass it in whatsoever you want, in whatsoever way you want. So in this case, I'm passing minimum child samples to 40, and if I see my light GBM now, it is 40, right? Or you could do something like this: import NumPy as NP, um, and then create a learning rate for I in np.a range 0.1 to 1 with a difference of 0.1. Create model light GBM learning rate is equal to I. Right, so now what you are doing is you are basically training 10 light GBM with a step of zero point 0.1 in learning rate. And you could do it, so especially when you're working with regression and you're working with parameters like alpha and lambda, you could actually use this kind of functionality and then visualize the relationship of parameter with performance on the ML flow front end. And I'll show you in a second what I mean. So at the moment, I've created a loop which is creating 10 different light GBM models with different learning rates. I don't need to be worried about metrics, parameters. I don't need to store it anywhere. I don't need to do anything because everything is happening in the background automatically, right? It would be a waste of time for me to actually track these metrics manually. Okay, so I think the training is completed. Now if I go on my front end, you would see all these light GBM, their metrics, so you can see here as well. But the better way would be to basically click on here and click on compare. Go here, put learning rate on x-axis and AUC. So you can see with the increasing learning rate on x-axis, AUC kept on declining. And obviously these are only 10 models, but when you would do a run on like 100 parameters, you would see a very, very meaningful visual, right? Okay, I think we have covered most of it. So one word, there is a lot of documentation tutorial on our website and our GitHub. Let me just show you. If you go to PyCaret GitHub, you would see tutorials. These are our official tutorials, a lot of notebook. You would see examples. There are over, so all these examples, and you would also see resources where you would see resources in English language. So they are like articles, right? So a lot of training material. Feel free to jump in. Our website is extremely user friendly, just like just like this website is very user friendly. Okay. I'll now open for questions. I can hear a lot of noise.
Okay, Moise. So thank you for a wonderful session. And my comments, if I am reading the comments, people are loving the session, the library, and your efforts you have taken to build it up. So kudos to you. And okay, let me just take questions around.
Yep.
Okay. How the libraries like PyCaret are created? What programming languages are working at the backend, and how much time is consumed in creating such? Looks like a competitor is coming.
So it started in a school last year. So in all, it took almost 1 year in a team of 20 to 25 people. It took 1 year to bring the first version out for PyCaret. But we are also actively developing now. Obviously, we have a compared to 1 year ago, we now have a very big community, and many people around the world are developing it. So obviously, things are moving faster, and but it took 1 year in the beginning to bring the first version out. Hello.
Sorry, there's some, I think, problem from my mic, so I'm not able to speak. By the way, Moise, can you go to the ask a question section? There are a lot of questions there, and maybe you can answer them.
Okay, so I think we are talking about the chat section, right?
No, no,
I
there's
think Moise.
ask a question section on the bottom of the
Oh,
screen.
okay. Okay.
Okay, you
Any
are.
specific reason?
Sorry, you were answering the second last question, how the libraries like PyCaret are created. So it got disrupted between. So can you please repeat the answer again?
Okay, so how libraries like PyCaret are created, what programming languages are working on the backend, how much time. So how it is created, I think it mostly stems from research. It could be research in school, it could be research anywhere else, but I think mostly it's coming from research. Programming language depend. In case of PyCaret, it's purely Python, but we are thinking about thin wrappers for other languages, especially R, but primarily it's Python. How much time it took? It took 1 year to bring the first version to production. So 1 year with a team of 20 25 people, almost like a full-time job. So it took a lot of time. Any specific reason not to include deep learning models in PyCaret? So I think that wouldn't be fair to wrap deep learning models like we wrap machine learning models in PyCaret. And I think deep learning is its own separate area. And I think including that in PyCaret, we would kind of lose our vision. Our vision is to target canonical classical machine learning. Do I need to uninstall version 1 before installing version 2? No, not necessarily. But if you do that, there is no harm. But you don't need to actually do it. What you can do is pip install PyCaret is equal to 2.0 is equal to 2.0, or you could do pip install dash dash upgrade PyCaret. All of it would perform the same thing. How long before we receive our certifications? I'm not sure. I think that's not for me. Any version of PyCaret for image data? Well, it's the same algorithm, right? So if you can convert your images into you can transport it into NumPy arrays, you can use that. I mean, I've seen a lot of tutorials on Kaggle. People have done that, but we don't provide any transformers specifically. MOEEZ, does PyCaret use sklearn behind the scene? Yeah, for the base library, I think sklearn is the most stable flavor, had the most stable flavor of versions. But PyCaret is not designed to be algorithmic library. That means that if you have your own model which is following a dot predict and dot fit function, you can use that in PyCaret. So it's not specific to sklearn. The fact that our model library has many sklearn models is because it's the most stable option out there. But if you want, you can work with the Interpret ML Microsoft framework, any Linux libraries, CUDA libraries, anything that supports fit and predict, you can work with that. What was the motivation behind the development of PyCaret? So last year, when I was finishing up my graduate school, I kind of see the shift happening of people coming into data science. Primarily, like 5 years ago, you would see two kind of people coming into data science, and mostly was computer science. But that shift is happening, and over 50% of the people now getting into this field have no quantitative background whatsoever. That they are not from computer science, they're not from statistics, they're not from mathematics. They're actually coming from marketing, HR, finance. So I see there was a need for a very user-friendly product in Python specifically, right? So that was it. Any plan to release a guide for PyCaret, kind of a handbook? Uh, do we have a working example? Sorry, this one first. Do we have a working example where we can generate intercept and coefficient? Yep, you would find it if you would see regression tutorials. You would find it, but obviously, if you are referring to like a statistical summary, vol test, and p values and all that, obviously, just like sklearn, we also don't support it. But you can obviously find intercept and coefficient. You can find.
Okay, there's another question. It's actually on top. So it's saying that PyCaret is kind of a one-stop shop. However, how it reacts to big data? Can it be used for meeting deadlines in soft or hard real-time systems?
So in terms of, so my answer to that would be, if today you can use your computer hardware using any other library, you would be able to use PyCaret as well, right? Because it's the same algorithms. But PyCaret do support GPU training. So if you are dealing with like 50 million raws, I would suggest use algorithms that supports GPU. At this point, you can use XGBoost, LightGBM, CADBoost. These have native GPU supports, and they are really, really fast, right? Especially XGBoost and LightGBM. They're really, really fast. For next release, we are also enabling um, uh, other GPU algorithms. So, for example, random forest and logistic regression will also be a GPU enabled algorithms. But no library. I mean, if you are trying to run KNN model on 100 million raws, no software or no library would be able to do it in your local hardware, right? So you either need to have GPU enabled training or you need to have distributed processing. So I think you can work with, there are ways you can work with big data, but obviously if you would run compare models on 150 million raws, I think your computer would burn.